Here's a line crossing a parabola, and the line crosses the parabola at 2 points. That means that those 2 points are on both the line and on the parabola. Another way of saying that is that they satisfy both equations. As written, this was given in intercept form. If you expanded this, you could get to standard form, ax squared plus bx plus c. To go to vertex form, first let's find the vertex. You can do that by taking negative b divided by 2a. So negative b turns out to be a positive 12. Divide that by 2 times 2, and you get 3. This is going to be the x-coordinate of your vertex. If you plug that into any of these versions of the equation, you find that your vertex is 3, negative 2. Notice if you plugged a 3 in here, and there's the negative 2. This is vertex form. You don't have to know how to get there necessarily. You just have to be able to recognize it. I have 2 zeros at negative 3 and at 2, so this is the factor x plus 3, and this is the factor x minus 2. And because it curves down, my a value is going to be negative. Maybe negative 1, maybe something else. So I'm looking for these two factors, and I'm also looking for this negative right here. The quadratic function opens upward, which tells us that our a value is going to be greater than 0. That rules out a and b. And then what happened if we picked, let's say, 1 for b, and 1 for c, and 1 for a? Those are all greater than 0. This would be my equation. So negative b over 2a would be the x-coordinate of my vertex, and this comes out positive, so that doesn't work. C is your best bet. If we were to expand this, you get that negative bx minus cx, that's your b term, negative b minus c. So by plugging in negatives for both, they stay positive there. So that way when you apply the negative 2b, or negative b over 2a rather, the negative stays around. So let's sketch these graphs. Here we start at negative 2, and the absolute value always makes it like this. But if we plug in a 0, we still get negative 2, so that doesn't work. If we take x squared minus 2, here we are at negative 2, and we have a parabola. But if we plug in 0, we still get negative 2, so that doesn't work. If we look at the same thing, x minus 2 squared, this is our parabola now. It's the same thing moved 2 to the right. And is y always greater than or equal to negative 1? I think that works. And this one, if you plug in a 0, you get a negative 2, so it does not work. C is the right answer. The parabola with this equation intersects with a line at 2 points. So I could say 25 is equal to x minus 11 squared. If I take the square root of both sides, 5 is equal to x minus 11, or negative 5 is equal to x minus 11. So add 11 to both sides. This one is 16. This one is 6. They want to know the distance between those 2 points. 16 minus 6, the distance is 10. If the graph crosses the y-axis at the point 0, k, what is the value of k? So that's when you plug in a 0 for x, which makes this part go away, and you're left with 12. The vertex of the parabola in the xy plane is 0, c. Then they ask about a different equation, or a different way of writing it. This is in vertex form, notice. My vertex is going to be b, c. And because of this negative, it's going to open down. So anyone that says open upward is wrong, and the vertex has to be bc. The y-intercept is when x is equal to 0, y is equal to what? So you plug a 0 in here, y is equal to negative 4 squared plus 3, or y is equal to 16 plus 3, or y is equal to 19. Here's another equation, and they want to know the value of its y-intercept. So that's when x is equal to 0, y is equal to what? So 0 makes these two parts go away, and the answer is 3.